All right, hey everyone. So this video is going to walk you through how to solve systems of equations that have three variables. So if you look at the question that we have here, we have x, y, and z. And now instead of two equations, we actually have three. So we're going to walk through a full question of how to solve this system when there are three variables. So the first thing that you're going to do is box your multiplying equation. So your multiplying equation, it's the equation where that first variable is a 1. So it's this first equation. Okay, and I'm going to box it. And I'm going to box it because we're going to keep going back to that specific equation. Okay, so we box the equation so we know that's the equation that I'm going to use. All right, we're going to leave that alone for a second, and we're going to write this as a matrix. And so we've done this in class before where you're just looking at the coefficients. So remember, the coefficients are the numbers that are in front of the variables. And so I'm just going to write a matrix or create a matrix, just the coefficients. So I have 1, 3, 5, and 45. So 1, 3, 5, and 45. I have 6, -3, 2, and -10. And so you're going right across 6, -3, 2, and -10. And then -2, 3, 8, and 72. So -2, 3, 8, and 72. Right? And so the 1, 6, and -2 should be in the same line because they all have x. And so 1, 6, 2, 3, -3, and 3. 3, -3, and 3, and so forth. So the variables, the coefficients that go with each variable should align in a single line that is vertical. Okay. So now we're going to look at which variable to eliminate. And so for us, we're always going to eliminate x first. Okay. So I'm just acknowledging that x is going to be that variable we're going to eliminate. So how? How do we eliminate that variable? Well, I'm going to take my multiplying equation and I'm going to write it at the top of both of my boxes. Okay, so I'm going to write it there, and I'm going to write it here as well. X plus 3y, 5z equals 45. And you actually want to give yourself a little bit more space than I did right here. And so each of these other two equations is going to go right under. So this second equation is going to go here, and the third equation will go here. So I have 6x minus 3y plus 2z is -10. And then I have -2x plus 3y plus 8z is 72. And you want to give yourself enough space. I could have shifted this over a little because you want to give yourself enough space to have at least kind of like half of the box left. All right. And so now what I'm going to do is I want to eliminate x, right? And so this goes back to that same section where we were talking about solving systems of equations. And we said, well, to eliminate the x's, the coefficients need to be opposites of one another. So my coefficient here is a 1, and I have a 6. So what is it that I need this 1 to be for it to cancel out with the 6? And so it's going to be the opposite of 6, which is -6. So I need this 1 to turn into a -6. And so I do that by multiplying it by -6. And so when I do that, I get -6x minus 18y minus 30z equals -270. Okay. And then my second equation I didn't touch, so I'm just going to bring it down. Okay. And so now my x's cancel out. -6 plus a +6 cancel out. And I'm left with -18 minus 3 is -21. So I have -21y. I have -28z because -30 plus 2z gives you -28. And then -270 minus 10 gives you -280. Okay. And I was actually able to fit it all in one space, but I do try to give enough space just in case you can't fit it all. I write a little bit smaller. All right, I'm going to do the same thing here, right? I'm canceling out these x's. I have -2 here. So what number or what coefficient do I need this x to have so that it can cancel out with the -2? And so a -2 only cancels out with a +2. So I need that 1 to turn into a +2. And I'm going to do that by multiplying it by 2. So I'm left with 2x plus 6y. And so just in case we didn't get it here, you're distributing, right? I distributed this -6 to everything inside the parentheses. And so that's what's happening here. You're going to distribute to everything inside the parentheses. And then my bottom equation I didn't touch, so I'm just rewriting. Okay, my 2x's cancel out. And I have 6 and 3, which is 9. So I have 9y. 10 and 8, which is 18z. And 90 plus 72 is 162. So now I have these two new equations. Okay, and those two new equations create my new system. So they're going to go into this box. -21y minus 28z equals -280. And 9y plus 18z equals 162. That's my new system. And so now we just go back to how we did solving systems with two equations, right? I'm going to solve my new system for one variable. So in this case, we'll use the first variable, which is y. And then the other variable is z. So I'll use this box to solve for z. Okay, so how are we going to solve for y? I'm going to start by just writing out my system. So I have -21y minus 28z equals -280. I'm just going to push it up a little so you can see a little better. And 9y plus 18z equals 162. All right. And so I want to solve for y. I want to eliminate y, right? That's the first variable I'm going to eliminate. And so remember what we did before. There's no relationship between 21 and 9. So 9 can't be multiplied by something to give you 21, and 21 can't be multiplied by something to give you 9. So we're just going to flip them. So 9 and -21. Okay, and remember, if I multiply 9 and -21, it's going to give me -189, and -21 and 9 gives you -189. And these don't cancel out. So I need one of them to be positive, so I'm going to change the sign of one of them. So instead of the -21, I'm going to do a +21. Okay, and so when you distribute your 9 to everything, you get -189y, -252y, z, and -2520. Now when you distribute the 21 to 9, 18, and 162, you get 189y, 378z, and 3,402. Okay, and so these will cancel out, and you're left with 126z, and I got that from -252 plus 378 equals 882, and that's by adding these two. You divide by 126 on both sides, and you're left with z is 7. Okay, and so this we've done this many of times. We're going to do the same thing, but now we're going to solve for z. So I'm going to rewrite my equation. Okay, but now I'm solving for z. And so the same thing I did here with flipping the coefficients, I'm going to do here, but I'm going to flip the coefficients of z. So that means 18 goes here and -28 goes here. Okay, and same thing, you need to change the sign of one of them, so this will just be positive. So when I distribute the 18, it gives me -378y minus 504z equals -5040. And when I distribute the 28, it gives me 252y plus 504z equals 4,536. and these cancel out. So you're left with negative 126y equals negative 504. And when you divide by negative 126, you get y equals 4. Okay, so now I have the value of y and z, and now I'm just left to find the value of x. And so I'm going to go back to what I started with. Any of these equations, I'm going to use the first one. And I'm going to rewrite it. So I had x plus 3y plus 5z equals 45. And I'm just going to substitute in my y and z. So I have x plus 3 times y, which is 4, plus 5 times z, which is 7, equals 45. So x plus 3 times 4 is 12. 5 and 7 is 35. These two I can combine, so x plus 47 is 45, and subtract 47 on both sides, and x is negative 2. So I have solved this system for all of my variables. X is negative 2, y is 4, and z is 7. And those are my solutions. And you actually can write it. Usually I write x comma y comma z, and I'll just put them in. So negative 2, 4, and 7.